Okay, now I'll explain how to solve numerical problems from this chapter. So this type of question you can get it in your board exam as well as in your school exam. The very first question I am taking, that one is find the time taken. They have asked you here the time taken. So first you write over here solution. So time taken is equals to, suppose let us say as t or t seconds. Then they have said by a 500 watt heater. So here I am underlining this 500 watt. What is this 500 watt? We can say as power. So power, we are writing just the symbol here. Power is equals to 500 watt. Then they have said you that the temperature of 50 kg material. So mass is equals to 50 kg they have given here. Then what they are saying here, that the specific heat capacity is 960 joules per kg per Kelvin. That means C is equals to 960 joules per kg per Kelvin. Again they have said the initial temperature was 18 degrees Celsius and the final temperature was 38 degrees Celsius. So you write initial temperature as 18 degree, final temperature as 38 degrees Celsius. Then finally you can write that del T, that means change in temperature, that is 38 minus 18 is 20 degree. That is change in temperature is 20 degree Celsius. Now let us calculate the rest of the problem. Again we go to the concept of class 6 and 7. In class 6 and 7 you have read what is power. Power is nothing but the energy per time taken. The same thing we are going to use here. So power is equals to energy by time taken. So here what is energy? Now here the energy is considered as heat energy. So we are going to write down here heat energy. That means is equals to Q by T. So you have to calculate T. So to find out the T, let us bring this T to the left hand side and we get T is equals to Q by P. Now what is Q? Here Q is the heat energy. So what is the heat energy? We know that heat energy here is mass multiplied by specific heat capacity multiplied by change in temperature. That is, since we know that Q is equals to mc del T, we are using the same thing. So here we can write it here. T is equals to Q means mc del T. Already we know that one, since this is equal to this, and what is mass? Mass is given in kg. So we write here 50 into specific heat capacity. It is also given in kg, kg per Kelvin. Then we are going to write down here 960. Right over here 960 into change in temperature, that is 20. Right over here 20 divided by, and the power is given 500 watt. Right here 500. So you get this cancel out. 5 ones 5, 5 tens 50. This gets cancelled out. So your answer is 1920 seconds. So now this you can calculate. This is your answer. Suppose in the board exam, if they ask you to change in minutes and hours, then you can just change it by dividing with 60. Minutes. 6 1 is 6, 6 3 is 18, 6 2 is 12. That is equals to 32 minutes is the time taken. This is your final answer. If they don't ask this, no need of writing, no need of spending extra time. You can just simplify over here and stop your answer. Thank you. Okay, one more numerical problem is a very important numerical problem. Often this type of numerical problem you might have seen in your test papers. This type of numerical problem often it comes in your board examination in ICSE examination. So before solving this numerical problem, we'll have one more concept. जैसे कि मैंने आप लोगों को पहले बताया था इस क्लास स्टार्ट करने से पहले कि अगर हीट एनर्जी देते हैं तो ये कोई जरूरी नहीं है कि हर वक्त उस सब्सटेंस का टेम्परेचर बढ़ रहा हो. कभी कभी देखा जाता है कि आप हीट एनर्जी देते हो, टेम्परेचर बढ़ता नहीं है लेकिन उसका फेस चेंज होता है. इस तरह का जब पद्धति हो तब उसको हम कहते हैं लैटेंट हीट. During latent heat, there is a change of state in the phase, but there is no rise in temperature. With that concept, we are going to go with another question. Let us solve this question. I am going to read out this question. Look over here. In the question, it is given that 2 kg of ice melts. So, I am underlining here 2 kg of ice. When water at 100 degrees Celsius, we don't know what is the mass of the water, but the temperature of water we know that it is 100 degrees Celsius, is poured in a hole drilled in a block of ice. Okay, it is poured. So let us draw a diagram here. Suppose this is a block of ice and here a hole is drilled. In this hole you are pouring water, certain mass of water, let that mass of water be m kg, which is at 100 degrees Celsius. Now what happens here? What they are asking you? They are asking you that what mass of water was used to completely melt this ice. That means what? When you are pouring the water of 100 degrees Celsius inside the grill of a cube of ice, that means the temperature of water decreases to 0 degrees Celsius. My dear, you have to know this one very first in this question after reading out. Now we'll try to solve out the answer. Again they are saying that the ice, it gets melted. So we see in the question they have not given you what was the initial temperature of the ice. In generally, you have to write it in the question, okay, that in generally let the initial temperature of ice be 0 degrees Celsius. Why I am writing here? Because in this question they have not mentioned what is the initial temperature of ice. So we can consider this one. So you have to answer in this way. Let us consider the initial temperature of the ice be at 0 degrees Celsius. When you are pouring water inside this, that means what? The ice is totally getting melt till 0 degrees Celsius in water. That means what? See again here, there is no change in temperature. That means whatever the energy is given here, it is latent heat. So now let us solve the question. The very first thing we have to solve, write here solution. In solution, you can draw this diagram, you can do the whole thing and can show, and then from here, for in the case of ice, we can write it down. Right here, in case of ice. So when you are pouring water, that means what? The ice is absorbing the heat. Ice is absorbing the heat. So heat absorbed by ice from 0 degree to change into 0 degree water, from 0 degree Celsius to 0 degree Celsius in water. So heat absorbed, here is latent heat we are writing. So we can write here heat absorbed is equals to m into L. So what is m? M is the mass of the ice, and the mass of the ice they have given here 2 kg. So write here 2 into latent heat. Again, the latent heat is given as 336 into 10 to the power of 3. Write down here 336 into 10 to the power of 3. This is in case of ice heat absorbed. When water is poured down, it was from 100 degree to 0 degree. So there is a change in water. There is a change in the temperature of the water, that is 100 minus 0, that is 100. So what happens over here? Heat lost by water. So you can write over here, heat lost by water from 100 degree Celsius to 0 degree Celsius. That is equals to, heat lost equals to, we can write m into c into del T, m into c into del T, which is equals to mass of the water we don't know, let it be m kg, write down here m into, we know what is c, specific heat capacity of water is 4200 into change in temperature is 100. Again, from the principle of calorimetry, which has been considered from the law of mass of energy, heat lost is equals to heat gained unless it is insulated. So we can write here, you have to write here, heat lost is equals to heat gained. So here heat loss is m into 42000 is equals to heat gain, that is 2 into 336 into 10 to the power of 3. From here we can get m is equals to 2 into 336 into 10 to the power of 3 divided by 42000. So this gets cancelled off from this, then 2 ones, so we get here 16 by 10, that is m is equals to 1.6 kg of water. In this way you have to solve the problem. Okay, one more question I'm going to read out here, and be careful to understand this question because often students get confused from this question in examination. So let us read the question first. In the question it is given that a piece of ice of mass 40 gram is added, I'm underlining here, is, why am I underlining here? I'll let you know afterwards, is added to 200 gram water at 50 degree Celsius. Calculate the final temperature of water when all the ice is melted. It seems the question is easy, but you have to understand the question very carefully. सबसे पहले यहाँ पर आपको तो पता चलना होना चाहिए कि आप इस क्वेश्चन को किस तरह से सॉल्व करोगे। तो यहाँ पर कह दिया गया है कि 40 ग्राम का जो आइस है, ये आइस को हमने 200 ग्राम वाटर में रखा हुआ है। सपोज यहाँ पर एक हम डायग्राम बना रहे हैं, यहाँ पर 200 ग्राम का पानी है, राइट हियर 200 ग्राम वाटर, 200 ग्राम का पानी है, जो पानी का टेम्परेचर लिखा हुआ है एट 50 डिग्री सेल्सियस, पानी का टेम्परेचर 50 डिग्री सेल्सियस। फिर आपने क्या किया है, 40 ग्राम का आइस, एक क्यूब जो है, ये आप इस पानी में डाल दिए हो, तो ये 40 ग्राम का आइस है। फिर लिखा हुआ है कि कैलकुलेट द फाइनल टेम्परेचर ऑफ द वाटर व्हेन ऑल द आइस मेल्ट्स। जब पूरा आइस पिघलता है तब यहाँ का जो पानी बनता है, इसका फाइनल टेम्परेचर आपको निकालना है। तो फाइनल टेम्परेचर हम 30 डिग्री सेल्सियस लिख सकते हैं यहाँ पर। तो यहाँ पर देखना है कि पहले आपने यहाँ पर आइस का कोई टेम्परेचर तो दिया नहीं है, तो आप यहाँ पर लिखोगे लेट अस अज्यूम द इनिशियल टेम्परेचर ऑफ आइस बी एट 0 डिग्री सेल्सियस। तो यहाँ पर आपका आइस का इनिशियल टेम्परेचर आप लिख दो यहाँ पर 0 डिग्री सेल्सियस। तो सबसे पहले क्या हो रहा है कि एक आइस हीट एनर्जी एब्जॉर्ब करेगा, करने के बाद 0 डिग्री सेल्सियस से 0 डिग्री सेल्सियस वाटर में कन्वर्ट होगा। ये तो पहला है कि वो हीट एनर्जी एब्जॉर्ब करेगा। जब जो आइस यहाँ पर जो 40 ग्राम का आइस जो पिघल रहा है, ये वाटर क्या है तब 0 डिग्री पे है, वो 0 डिग्री से फिर क्या होगा, फिर हीट एब्जॉर्ब करेगा, एब्जॉर्ब करने के बाद T डिग्री तक चढ़ेगा वो। तो यहाँ पर आपका 3 प्रश्न बनता है। तो पहला प्रश्न है, पहले हम धीरे धीरे करेंगे, हीट एब्जॉर्ब्ड बाय आइस, नंबर 1, हीट एब्जॉर्ब्ड by 0 degree Celsius ice to change into 0 degree Celsius water। तो यहां पर आपको 40 ग्राम दिया हुआ है, तो एब्जॉर्ब कर रहा है, फेज में चेंज हो रहा है, कोई टेम्परेचर में तो चढ़ नहीं रहा है, इंक्रीज नहीं हो रहा है, तो यहां पर लैटेंट हीट का यूज किया जा रहा है। तो पहले इसका हम तो लिखेंगे हीट एब्जॉर्ब इज इक्वल्स टू मास, यहाँ पर 40 ग्राम दिया हुआ है, तो 40 ग्राम को हम किलोग्राम में चेंज करेंगे। सो 40 बाई 1000 इंटू एल। आपको पहले फॉर्मूला लिखना होगा एल यानी कि लैटेंट हीट ऑफ आइस का जो बनता है वो है आपका 336 आई थिंक। तो लैटेंट हीट है 336 इंटू 10 टू द पावर ऑफ 3। तो यहां से और ये कट होता है, तो ये आपका बनता है 4046 4 24 0 6 4 4 6 24 4। सो इतना हीट एब्जॉर्ब कर रहा है 0 डिग्री वाटर आने के बाद। अब क्या होगा, नंबर 2, सेकेंड स्टेप आपको क्या देखना है कि आइस तो हीट एब्जॉर्ब करके 0 डिग्री आइस तो 0 डिग्री वाटर में बन चुका है, और 0 डिग्री वाटर जो था वो 40 ग्राम आइस का था। अब ये 40 ग्राम आइस फिर से हीट 40 ग्राम आइस का जो वाटर है फिर से हीट एनर्जी एब्जॉर्ब करेगा, करके उसका टेम्परेचर T डिग्री तक लेगा। दैट मींस द चेंज इन टेम्परेचर इज, दिस इज द फाइनल टेम्परेचर, सो चेंज इन टेम्परेचर इज T डिग्री सेल्सियस माइनस 0, दैट इज T। सो अगेन राइट heat absorbed by 0 degree Celsius in water to change at T degree Celsius. Hence 0 degree से T degree का बनता है, so it is T minus 0, that is del T is equals to so change in temperature is del T. That means T minus 0 is T. So then here, since the temperature is being increased, so no more latent heat is energy is used. Here specific heat has been used here. So we write here heat absorbed is equals to, the formula you write mc del T. M is mass of ice, mass of water was 40 for ice, 40 by 1000 into specific heat of water is 4200 into T. That is 168 T. So the total heat absorbed is 168 T and 13440. Okay. Now, third step. Here the water was 200 gram. It has been at 50 degrees Celsius and final temperature has been changed to 3 degrees Celsius. So again specific heat capacity of water we are going to use here. Now we are going to write down this water has lost its heat energy. So heat energy lost, HL, we are going to write down by water from 50 degrees Celsius to 3 degrees Celsius. That means here delta is equals to 50 minus T. Then by the formula we are writing mass. Mass was 200 gram. That means 200 divided by 1000. We are converting it into kg. Into specific heat was 4200 into 50 minus T. So we are getting here so automatically we are getting here that is 20 into 42 into 50 minus T. That means so by doing the simplification, we get this. Again, now you have to write down over here by the principle of calorimetry, heat loss is equal to heat gain. Heat loss is equals to heat gain. So here the heat loss was this one. So we are going to write down 42 minus is equal to, and the heat gain already we have done, that is 13440 plus 168 T. Now we bring out this one here and subtract, we get 0. 0, 6, 4, 5, 5, 4, 8. So we are getting this. Okay. Now this is equals to minus 840. If you come also here, it becomes plus. So 840 plus 168 is 8, 6, 4, 10, 8, 9, 10. Therefore, P equals to 28560 divided by 1008. Let us divide with 7 first. 7 4s are 28, 7 zeros, 7 8s are 56, 0, 7 1s are 7, 7 4s are 28, 7 4s are 28. Now let us go with 2 7s are 14, to 2040. Again with 4 we can cut it out here. 4 ones are 4, 4 5s are 20, 4140. Next 3 6s are 18, 3170. Then 170 divided by 6. That means we are getting 6 2s are 12, 6 8s are 48. Again we are getting, so we can write here 28.3 bar. So finally your final temperature will be equals to 28.3 bar degree Celsius. Thank you. Suppose if you have any problem regarding how to solve the numerical problems, you can comment in my comment box, and further if you want to ask personally, you can let me know through your contact number. Thank you.